Hey y'all, so in this video we're going to practice balancing some equations. We're going to identify types of reactions, and of course we're going to use our periodic table to help us with all of that. Okay? So in the first questions, all it wants us to do is identify the type of reaction and then balance the reaction. So they've already got the elements and the molecules figured out for us, so they already did the first step. Remember in class we said first we have to figure out what the products will be. We have to figure out the electrons and match those and figure out how many of each atom. We're not going to have to do any of that here, okay? That's already set up for us. We'll do that in the second part if we have time, okay? Right now, we're just going to identify, and then we're going to balance by putting numbers in front to make sure that we have the right number of atoms on each side, okay? So here we go. Let's give it a shot. So the first one, we have sodium bromide and chlorine, which is turning into sodium chloride and bromine, okay? So what we see is that the bromine has been replaced by the chlorine, right? Those two have just flip-flopped. That is a single replacement or a single displacement reaction, okay? So what's the type? It is a single replacement. There we go. First one done. Single replacement. Now we need to do the balancing. So to do the balancing, you're just going to look at each atom, make sure that it's balanced. If it is, leave it alone. If it's not balanced, then you're going to add a number in front of one of the molecules to make sure that it's balanced out. Now, at some point, you'll want to go back through and double check because adding numbers will sometimes unbalance some of the others. So let's see. If we start with sodium, Na, I see I have one here and one there. So that's totally okay, right? Then I move on to the bromine. The bromine, I've got one there and I have two over here. And so I need to put a number in front so that I have the same number on both sides. Well, I got two here and one here, so I can solve that by putting a 2 in front of that. So now I have the same number of bromines. Now, you may notice right away that now I've got 2 sodiums. Okay, now if you notice that, you can go ahead and change this, and you can say, well, that means I need 2 sodiums here as well. If you don't notice that right away, it's fine. You'd go to the chlorine, and you say, oh, there's 2 chlorines, so therefore I need 2 chlorines over here, and you'd put the 2 in front anyway, and then you would go back and double check. So at this point, I feel like I've done everything that needs to be done, so let's just go double check. I have 2 sodiums, I have 2 sodiums. I have 2 bromines. Remember, this is a group, so that means 2 of each of those. So 2 bromine and 2 bromine. I have 2 chlorines, and I have 2 chlorines. So therefore, we did it. We got it. That's not too bad, right? Okay, let's try another one. Sometimes if we don't have to come up with the products, it's a little bit easier. All right? So let's look at the second one. So I've got mercury oxide, which is turning into mercury and oxygen. Okay, notice that the O is O2. Why is it O2? Because that is one of our diatomics, the BrINCLHONF, Brinkelhoff. Those are the elements that will never be by themselves. So that's why oxygen is going to be with another oxygen here. Okay, now if we do the balancing, we say, well, mercury looks okay. Right? Oh, what type of reaction? Well, we have one thing that's being split into 2 different elements. Okay? So that is a decomposition. So I go I can spell composition. Okay? If you don't know how to spell it, look it up. You got it in your notes, right? So decomposition. So now I look at the mercury. Mercury is the same, so 1, 1. I'm okay with that. I look at the oxygen, I got 1 oxygen here, and there are 2 oxygens here. So I go, oh, I guess I need a 2 in front of this one. Now, of course, having 2 oxygens here checks out, but now I've got 2 mercuries. I go back and I double check. Now I got 2 Hg, 2 mercuries, so therefore I need to make sure that I also have 2 mercuries here. And so there, I've now balanced the equation. 2 mercuries, 2 mercuries. 2 oxygens, 2 oxygens. There we go. Question number 2. Not too bad, right? If we're not trying to do the whole thing, just that little part, balancing the equations, it's actually not all that bad. All right? So, here we go. Let's get rid of these. And we're going to move on. Okay, I'm not going to write the type of reaction anymore because I think that you can figure that out based off of what you're seeing. All right, so here we go. Numbers 3 and 4. So we've got aluminum that's being mixed with copper nitrate. Okay, now the NO3, it's in parentheses, that's actually what we call a polyatomic ion. So what that means is it's a group of different atoms that group together, and yet they act like a single atom, okay? Because they have a specific charge. We're not going to worry about the charges right now, but recognize that that will be one thing, right? And we actually see that here in that we start with aluminum and copper nitrate, and now we have aluminum and the nitrate, right? So what's happened is the aluminum's come in, and he said, I want this spot, and then the copper goes off by itself. So this is a single replacement. So we got a single replacement here. You can write that down, single replacement reaction or single displacement reaction. Now we're going to go through and try to balance. Okay, so I see one aluminum here. I see one aluminum there. We're starting off good. Then we go to the copper. I see one copper here. I see one copper there. All right, no problem. Now I get to this one. I see two NO3s. So I got two of those nitrates here. Now I look here, and there are three of them. Ugh, how am I going to balance that? I got two here and three of that group over here. Well, you may have heard of something called the least common multiple. You learned about that in math class, hopefully, at some point in time. Even if you don't know the word, that's just the smallest number that two and three go into. So hopefully you recognize that those both divide into 6. 6 is the smallest number that's divisible by both the 3 and the 2. So we want 6 NOs here, right? So we want 6 NO3s here. So I got 2. So I'm going to put a 3 in front because I'm going to have 3 of those 2's now. 3 times 2 is 6. All right? Over here, I already have 3 in this group. So to get 6, I'm going to put 2. So that means I now have 2 sets of 3. You don't have to worry about the NO3. You don't have to worry about that 3 inside because that's part of this polyatomic ion. It's part of that group. So all we need to worry about is getting these matched up. I got a 2. So 3 times 2 is 6. Now I got 6 of those nitrates. Over here, I got 2 times 3. That would now be 6 of those nitrates. Now, I got to go back and double check all the other elements, right? So I have 1 aluminum here, and I've got 2 here. So that's pretty easy to solve. I just put a 2 there. Now I have the same number of aluminums. And then I see 3 coppers here. So I need 3 coppers on the other side. So I'm just going to put a 3 there, and that balances the coppers, right? So again, not too bad. It was a little challenging dealing with this new idea of the polyatomic ion, but all in all, not too bad of a problem, okay? Now, let's move on to this one, okay? So we have silver, Ag is silver iodide, plus sodium sulfide, okay, Na2S, and then it switches to Ag2S and NaI. Now, this one, you won't have to do this right now because it's already set up for you. But you can figure out, Ag, we talked about in class, these elements here in the middle, they're a little bit weird. They do some strange things sometimes, and we have to figure out what's going on with those. So I want to introduce you to this idea because it might be helpful with some of the later questions. All right? So AgI, we know I is right here, right? I is in that next to last column. Those are the ones that have 7 electrons in the outer shell. Now, because it has 7 electrons in the outer shell, it wants to get one more. When it gets that one more, it'll be negative. So that I is -1. So in order for the silver to match up with it, the silver there must be a +1. Otherwise, they wouldn't have bonded in the first place, right? It has to be. Even though we can't really tell from here what it is, it has to be a +1. Okay, when we look at these, S can be a little bit difficult, but it is right there, right? S is right there. We do know that sodium, Na, is right here in the first column. The first column has 1 extra electron, 1 electron in that outer shell, so it wants to give it away. When it gives away that negative, it's going to be positive. And you'll notice that I have 2 of those positive ones. Therefore, hopefully, sulfur is a -2 so that they match up. And sure enough, the row right here with fluorine, that was -1. And then this column right here, that would be our -2, right? They have 6 electrons, and so they're going to take 2 more so that they can fill up and have 8 in that outside shell. So that works out, okay? Now, obviously, we didn't have to do that here, but I wanted to show you that sometimes we can figure things out because of what they're bonded to, because we know why those things are bonding, right? So this would be like an 8 question. Right? If we were given this and the question was, well, what's the charge on the Ag? Well, we don't know by looking at our chart, but we can figure it out with the knowledge that we have. And I will have you do some of this in the second part of this assignment. Okay? So if we look at this, we now start, we can go ahead, so it looks like we have AgI and Na2S. Notice that the S and the I swapped places. Right? You had AgI and Na2S. Now the S has gone over to the I, and the I has gone over here with the Na. So that's what we call a double replacement or a double displacement reaction. All right? So that's what the type of reaction is. It's a double replacement or double displacement. Now we can go through and we can do some balancing. I'm going to look at the silver first. So the silver is 1 Ag here. And I see 2 Ags over here. So right off the bat, I'm going to put a 2 right there with the AgI. So now I've got 2 silvers and 2 silvers. I now have 2 Is. So I come over here and I see, oh, I only see 1 I over here, so I'm going to have to put a 2 there. So now I've got 2 Is here and 2 Is there. I have 2 sodiums there, which is okay because I got 2 sodiums here. That's already balanced. And then I see 1 sulfur there, and I see 1 sulfur here, so that's already balanced. Okay, we can go through and double check, but it looks like 2 silver, 2 silver, 2 iodine, 2 iodine, 2 sodium, 2 sodium, 1 sulfur, 1 sulfur. Everything's balanced. That's it. So just look at one at a time, and then when you finish, always double check. Go back and make sure that you don't need to add anything else in. Okay? So hopefully that was helpful for the first part here. I'm going to go ahead and stop this video here, and we'll see if we can put together another one with some of the other types of questions, all right? We'll see you later.